Q to CyberGhost VPN for
You guys hear
supporting
that?
PBS. Did you know that many of us have up to 4% of our DNA from Neanderthals, and that 100% of us may have 100% of our DNA from outer space? No joke. At least
yeah.
the
This is
biochemistry
where he's going.
that defined the coding system of your DNA may have happened off-world, and perhaps even long before Earth existed.
This guy's great though. If you guys don't watch, if you guys are interested in physics, PBS Space Time is a dope
Before
channel.
we get started, I just wanted to let you know that we have some new merch at the merch store celebrating 10 years of Space Time. We've got a
Have you guys
limited
seen this
edition
before? Have you guys
10-year
watched
anniversary
PBS Space
design,
Time?
as well as some classic logo merch. Having this gear doesn't just make you incredibly cool, it also helps us keep going for another decade. Life is the coolest thing to have happened in our universe. It would be nice to know if it happened anywhere else besides Earth. If nothing else, to know just how badly we're screwing up as we flirt with self-extinction. But not only have we never found credible evidence of life on or from other worlds, we only have the sketchiest of ideas of how it began on Earth. Makes it pretty difficult to say.
Yeah, but I think with the Drake equation, and obviously with, if you think about the universe as being infinite, there's obviously life. There's no question. There's no question that there's life somewhere. It's just, have we interacted with that life? I think is what he's trying to get at.
Much about what's happening out there. But one encouraging detail is just how quickly life got started on Earth. The earliest fossils are dated to within a few hundred millions of years after Earth first cooled from its early molten hellball phase. And if you believe some of the more tentative biosignatures, it could be much earlier. In fact, life got started so quickly on Earth that some have argued that natural selection just didn't have the time to take raw elements all the way to the first single-celled life form. This difficulty has led some scientists to propose panspermia, the idea that life did not.
Let's see. Pigeon on the rooftop. Are you talking about Fermi? Is that what you meant to type? Not Femi? The Fermi paradox? Like the longer we go without running into life, the more likely we are by ourselves. Or is that what you're talking about? Yeah, the Fermi paradox. Yeah, it's either the longer we go without running into other life forms, the more likely it is that we are the only life form. But we haven't been around that long. I mean, we don't know if there was. We think that it's like, oh, there's been no other life forms that have came to Earth for 4 billion years. That's not necessarily true. I mean, there could have been plenty of aliens that visited, and I'm not saying that they have. I'm just saying conceptually we could imagine that before our written history, there were visitors, and maybe they stayed and maybe they didn't. But to assume that, oh, in the past 2,000 years we have nothing documented for the public, that means they don't exist. It's just kind of out there. As a scientist, I've got my degree in physics. As a scientist, for me, it's preposterous to say that there's no other life. Let's see where he's going with this, though.
Not start on Earth at all, but rather travelled here in the form of extremely simple and presumably extremely robust organisms. It's a fun story, and we've talked about it before, but it's not supported by evidence and generally not considered particularly likely. But there is a middle road. Perhaps life didn't start in space, but maybe its building blocks did. Pseudopanspermia is the idea that many of the complex molecules critical for abiogenesis, the formation of life, were not formed on Earth, but rather in the depths of space, in some cases long before the formation of Earth itself. If these then rained down on our...
Yeah, this is the idea that there was, some sort of RNA on a meteor or on a bunch of meteors that then, fell within Earth's gravitational pull. I think is what he's talking about here.
Planet in its early years that would allow our molecular ancestors to skip many of the steps in their path to the first cell. The evidence for pseudopanspermia is rather strong, and the most compelling of that evidence is just in, with the safe return of Osiris Rex. But before we get to those results, let's review what little we know about the first formation of life. Life as we know it is based on a complex interplay of...
Let's see. Feral wild pigeon on the roof. Yeah, go ahead, give your thoughts in the chat. I'm not bringing people up, but go ahead and give your thoughts in the chat. That ultimately doesn't matter, since we have proof like life exists with the laws of physics. Yeah, exactly. Well, it's the Drake equation, really. And yes, you're right. The fact that we're here means that there are conditions that could be duplicated anywhere an infinite number of times throughout the infinite universe for life to exist.
Of organic molecules, primarily nucleic acids, proteins, lipids, and carbohydrates. In your body, these
pigeon on the rooftop. If it's too long to type, we do bring people up. So, just give us a follow. The next time we go live and we have community engagement, we'll bring you up and we can have the conversation. But I have to watch these videos, so I'm just watching them with the community and interacting with chat. That's what I'm doing today.
Work together to form the intricate machinery of the modern eukaryotic cell. Of course, the first life was much simpler, and life's precursor simpler still. For example, self-replicating RNA molecules of the RNA world hypothesis. But how did a bunch of non-living chemicals even get to something as complex as RNA? Extremely broadly, we assume that there was some energy and chemical-rich primordial soup where simple elements combined into organic molecules, then combined and recombined in a chain of trial and error until this natural laboratory first stumbled on a self-catalyzing and then self-replicating molecule. The step from organic molecules to complex self-replicating RNA is still mysterious, even if there have been recent advances. But the pre-RNA part of the story, we've known that's possible for decades. Back in 1952, a pair of scientists attempted to replicate the conditions of the early Earth, with a liquid water ocean evaporating into an atmosphere of hydrogen, methane, and ammonia. An electrical spark simulated primordial lightning, powering a chain of reactions that ultimately led to a variety of organic compounds, including 5 amino acids, the building blocks of proteins. This was the famous Miller-Urey experiment, and it was our first hint at how the seeds of life may have formed. That experiment has now been repeated in a variety of ways, and we now know that amino acids can spontaneously form given the right raw materials, an aqueous environment, and an energy gradient. The apparent ease with which amino acids form has led scientists to wonder just how ubiquitous these organic molecules might be, not just on Earth, but through the universe. For example, in the chunks of rock and ice that rained down on the early Earth, first building our planet and then perhaps seeding it with the precursors to life.
Well, what's a cool little side note here is all those rocks raining down, right? All the water came from that, right? The water wasn't naturally created here on Earth. It had to have come from somewhere else. So we had to have been getting bombarded with some sort of icy meteors. So it's an interesting concept that within those there was some sort of RNA. Who made the water? Well, you mean who made the water that was on Earth, or who made the water that was? I think I just explained. Obviously it wasn't here, right? It came, and to think that all the water here is water that has been here for billions of years. It's been here, and it's just recycled and reused and recycled and reused and recycled and reused. It's pretty amazing to think about all the water on this planet has been on this planet, but wasn't native to this planet. And it had to have come from another planet, right? Where do all think about the Big Bang and think about where all of the elements come from, right? They all come from this idea of stars performing some sort of fusion, and then supernova, or it collapsing on itself. If it's too large, it becomes a black hole, right? If not, there's a huge supernova and it explodes and it sends shards of itself hurling across the universe. Henke from another dimension created the human body. I'm not sure what the Henke are. I'd have to do some research on that. But yeah, I mean, there's more dimensionality than 4D. I mean, to me, there's no reason why we couldn't say that theoretically that there's more dimensions than 4 dimensions, right? And we just experience perception within these 4 dimensions. Is that hygienic? Well, the water luckily can sterilize. Right when it evaporation removes particulates from the water, so when it evaporates, it's kind of like a cleansing process. So when you see steam rising, it's kind of like a cleansing process. I mean, it's a good way to look at it. Rainwater is generally always clean water unless you start to deal with pollutants that, where we're in a situation that don't occur naturally, and that's where we're at now. That's why we can have what's it called, acid rain. But you wouldn't have seen that before man started developing those types of things. I want to talk about that. Hey, I appreciate it, but I'm not having the community up right now. I gotta stick to my guns on this one. We're just gonna watch the video. We're gonna talk and chat. We're gonna have conversations. But when we do communities and have people up, community lives, just make sure we have the conversation then. We go live all the time.
First pieces of evidence that space rocks are packed with organic compounds was the Murchison meteorite.
Just real quick, right? The idea of today is to interact with the community, the whole community. So anybody in the chat that wants to hang out, I'm going to answer questions. I'm going to do my best to read out the comments. And we're just going to talk about DNA, and the next video is going to be a DMT video.
Which fell in Australia in 1969. This is a carbonaceous chondrite meteorite, so mostly made of carbon, clay minerals and water, but it was also found to contain over 90 different amino acids, including some that are not commonly found on Earth, as well as the nucleobases purine and pyrimidine, which are critical components of DNA and RNA and other organic molecules. Carbon dating estimates that Murchison is around 7 billion years old, so a couple of billion years older than even our Sun, meaning that complex organic chemistry would have been occurring in space long before life ever emerged on Earth.
Wow. And that's obvious, I think, to most people, but I think most people don't think about it. When you stop and think about, oh yeah, there's things around on Earth that's older than the sun, our star. Well, yeah, because things travel through. We're not the center of existence as much as people might want you to believe. We came around sometime in time after the Big Bang, right, and formed. And there's plenty of stuff that was before it. You had huge stars, right? You had these huge stars performing fusion well before our sun did it. And even larger stars doing it on even heavier elements. So, yeah, no surprise, but it's interesting to think about.
It's hard to be 100% certain about the origin of the molecules found in the Murchison meteorite because the rock was in contact with the Earth, which we already know is infested with life. However, the amino acids in this meteorite had one distinct difference to those typically found on Earth. They came in both left and right-handed varieties, both chiralities, both mirror reflections. But all amino acids produced by Earth life are left-handed, a chirality that's been locked in since the first common DNA or RNA ancestor of all life won that great molecular war 3.5 to 4 billion years ago. The presence of both chiralities in the Murchison meteor tells us that these amino acids had an abiotic origin, supporting their pre-life formation. Pretty convincing? But the best way to be sure there's no cross-contamination from earthly life is to get samples directly from space. And there have been some incredible efforts to do this. NASA's Stardust mission collected samples from the coma of Comet Wild 2 and returned them to Earth. The Japanese Space Agency was the first to land on an asteroid and return samples, twice actually, with Hayabusa and Hayabusa 2. And ESA's Rosetta mission was the first to send a lander to a comet where it...
Real quick, Feral Wildchild has saying some things. Let's see, but space appears to be, and I'm looking over here because that's where my chat is. Let's see, but space appears to be expanding equally from any point viewed within it. That's exactly right. From any point, all points are the center of space, which means your point of perception is the center of the universe. That's exactly right, which only makes sense when you realize that it is hyperbolic projection. I'm not quite sure what you mean about that. The image is not flipped upside down and turned left and right on the retina. The three-dimensional expression would be that lights is turned inside out. Yeah, yes, you're adding some theory to that, but yes, of course, every point of space is equally expanding outward from it. It's hard to imagine something that expands equally from every point And then it doesn't matter what point you're at. There's always expansion outward from that point. It's a very interesting point that you brought up there. This world is just a simulation. We need to wake up. Hey, and we, the simulation principle. So we have a book that's coming out. We have a book out called Dawn of the Nameless One that talks not really about the simulation, but our second book that we're working on, that's like the companion, talks about, okay, is it a simulation, and what does it mean to be a simulation? And let's give definitions. The video we watched 2 days ago was with Sean Carroll and Lex Friedman. So if you didn't get a chance to catch that, you can go to our YouTube channel, Universal Theory, and I'm going to drop the whole video there. But essentially, they talk about simulation theory, and Sean Carroll doesn't believe it's a simulation, and what is computation. And I won't, that's just kind of the highlights from some of it. But Lex was essentially tearing Sean Carroll up politely, and with the questions that he asked. But yeah, of course, I mean, it's more of every point in space has specific ways in which it can interact with different types of energy. So when energy moves through it, there's all sorts of probabilities that can happen as that energy moves through that. And if you want to think of that as a simulation, I don't think there's a problem with seeing that as a simulation, or thinking that, hey, when when there's astral projection or other aspects of reality happening that a lot of people have experienced, and that's why we're going to go to the DMT video next. Where are we when we're doing that? We're in some sort of a vehicle. There's some sort of a vehicle there, but is it the same vehicle as here? I don't think so, because we're not moving the physical body when we're moving that body. So obviously there's something more than just this physical realm. Not that it makes this physical realm any less important. It's just not the only thing. All right, let's keep going.
It analyzed samples on location. These and other missions have shown that organic compounds are abundant on space rocks. But how far along can this prebiotic biochemistry really advance in space? How much of a head start might pseudopanspermia have given to life on Earth? Some of this has now been answered by NASA's OSIRIS-REx mission. In our long tradition of unwieldy science acronyms, this stands for Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer. The spacecraft launched in 2016 with its sights on an asteroid by the name of Bennu. Bennu is a pretty ordinary carbonaceous asteroid of middling size at around 500 meters in diameter, is part of the Apollo group, a collection of more than 20,000 asteroids with orbits that cross Earth's. That means they do sometimes slam into our planet, like the one that exploded over Chelyabinsk in 2013, or as in 2024 YR4, which has a minuscule chance of hitting Earth in 2032. Bennu has no immediate chance of hitting us, but it does make a close approach to Earth of around 300,000 kilometers or 24 Earth diameters every 6 years. The upside of these potentially cataclysmic neighbours is that they're quite easy to visit, which OSIRIS-REx did. It started that journey in orbiting around the Earth, followed by a mad dash to catch up and orbit the asteroid. Then after a few years of observation and analysis, a suitable landing site was identified and the spacecraft touched down. Samples were collected before an easy escape from Bennu's frankly pathetic excuse for a gravitational field. OSIRIS-REx rejoined Earth's solar orbit and dropped its sample capsule into our atmosphere in September of 2023. And after all of that, the capsule's parachute failed. Its first parachute failed, the second opened just fine, and the capsule landed right on target in Utah. Since then, scientists have been hard at work analysing the sample, and the first results of the findings were finally published in January this year. So, what did we find? Among the most exciting discoveries in the sample are all 5 of the nuclear bases that serve as the code for DNA and RNA.
Yep.
This is the first time we've found all 5 on the same space rock. The samples also contained 4...
Wow, that's kind of mind-blowing right there. Just let that sink in. All of the nucleotides within our DNA was found, the nucleotide basis, right, from our DNA was found on this meteor that's orbiting Earth. So, I mean, you could say, well, maybe it, if Earth got hit by something and it knocked a piece loose, it could just be that piece floating around. I don't know if we're going to get into if it's older or not, and maybe I missed that, but let's see.
14 of the 20 amino acids that life on Earth harnesses to make proteins. These amino acids have both left and right-handed chirality, just like the Murchison molecules. The Bennu sample has various other interesting compounds, including a surprising richness of ammonia, 12 times higher than in the Murchison meteorite. Curiously, Bennu orbits too close to the Sun to preserve pure ammonia, so that richness hints at a colder, more distant origin, but more on that later. One of the most exciting finds were 11 different minerals that we know form when...
Sorry, so because I'm interacting with chat, guys, this is how it's going down today. Farrell, I'm not sure, Einstein's equations of, especially if we're talking about general relativity, if you were to reverse the curvature, things would fall away. So as opposed to things falling towards it, it would fall away. I mean, we can have that conversation, and I can look more into it, but in my, everything as far as with the curvature of space-time, when you have a gravitational field, things fall towards it. So reversing that curvature would have things fall away from it, I would believe. And yes, people do not like accepting the fact, free will and the fact that we're not alone. People just, there's certain topics that just scare people, and it's fine. We're building a community of people that love to talk about things like free will versus determinism, and the fact that we're not the only individual, we're not the only life forms in the universe. It's just preposterous to even assume that, especially if you believe the age and the size. Then it's just insane. Sean Carroll was talking about that on the video we watched yesterday, and he believes that we're the only life. And it's like, come on, man, you're a physicist. You're smarter than that. And Lex politely, corrected him. I highly recommend that video. I want to meet aliens. I do too. I'd love to. I mean, regardless. I mean, I would find it very fast. I think it's something that we need. I think Earth is getting ready to meet other life forms. I mean, we're building towards leaving and going to other places. Maybe that's what it is. There might be a threshold that our technology has to reach a certain point before we are able to interact with some of these other life forms. But I'm excited about the possibilities of AI and machine learning, and the possibilities of terraforming and going to other planets and having a network of planets as opposed to just Earth.
And brines slowly evaporate. That means Bennu, or the stuff that formed it, was once in an aqueous, salty environment. In fact, there were many signs of the role of water in Bennu's formation. Its minerals match most of the water-altered meteorites ever found on Earth, as well as the samples collected from the asteroid by JAXA. But unlike most meteorite samples, Bennu contains sodium-rich salts, which are rare in meteorites. Similar salts are found here on Earth, like in Searles Lake, California, confirming that Bennu once contained pockets of sodium-rich water. But normally we don't find those sodium-rich salts in meteorites because they react strongly with our atmosphere. But because Bennu's samples were stored in pure nitrogen, they maintained a pristine suite of salts for analysis. And with this analysis in, we're able to reconstruct a likely origin story for this asteroid. And that origin is probably a water-rich world that existed for a time in the early solar system, but has since been destroyed. Let me take you back 4.5 billion years ago.
So a water-rich world is important because, life forms, they think life forms here, water, we came from the water. And then we moved to the land, but we came from the water. So finding a meteor that had a water-rich life, or a water-rich environment, that's huge, especially if we could try to track any. I mean, it probably doesn't exist anymore. Like he said, it probably is annihilated for some reason. But it's more and more evidence pointing towards life. It's like, how much do we need? How much evidence do we need?
To the icy fringes of the early solar system beyond Jupiter's orbit. A distant protoplanet is forming from a mixture of rock, metal, and frozen water. As radioactive elements created in an ancient supernova decay within, heat melts some of the ice, creating mineral-rich reservoirs. These ancient waters interact with ammonia and formaldehyde, sparking the formation.
So the problem, though, you're right. I mean, what holds us back is the persistent relics of logical positivism and reductionism paradigm. Yeah, I mean, the reductionist, though, to me, that argument, no, like I used to have a trouble arguing against the reductionist because it's like, yeah, the more fundamental, the smaller, the more fundamental, the smaller, the fundamental, the fundamental. But then I watched some John Vervaeke, and he's brilliant. And he got it from somebody else, I believe, and he gives credit to that individual. But it's like, okay, a reductionist will say, I'm using a microscope, or I'm using something, an emergent data structure, to measure the fundamental reality, to tell me that what I'm using to measure that fundamental reality isn't real. It isn't fundamental. So it's like, well, like, how does that work? That's like saying you're using math to disprove numbers. It's like, no. You can't use math to disprove numbers. Obviously, there's something wrong with your logic. And, once I got a hold of that argument, reductionism, you're right, it's a problem with left hemispheric thinking. Obviously, we need both. We need left and right. We need to be able to utilize all aspects of the brain when it comes to whether we're breaking things down and labeling them, or looking at the interconnected nature of everything, and from a holistic point of view is what people like to say. But yeah, to me that just destroyed the reductionist argument.
Of complex organic molecules. When the water eventually evaporates, it leaves behind veins of brine-sourced minerals. This protoplanet, however, is doomed. Before it can grow to full planethood, a catastrophic collision, perhaps with a similar body, scatters its fragments into space. And Bennu and many other asteroids pull themselves together from this debris. In the unsettled early solar system with its wandering gas giants, Bennu's orbit was also fated to wander. Eventually, it settles into an orbit perilously close to an inner solar system planet. A planet that would slowly turn blue-green and then twinkle with night lights, and then send a tiny visitor of metal and silicon named OSIRIS-REx. Or at least, it seems like this is the most likely story, based on the bits of Bennu that we brought back home. And if Bennu has the variety of organic compounds that we discovered, so do many asteroids, and probably comets. Many of these peppered the early Earth, far more than today. In fact, they are kind of what the Earth is made of. Like I said, pseudopanspermia, the idea that the chemistry of life got a head start from space molecules, is pretty well supported. But does this tell us anything about the likelihood of life elsewhere? We can be pretty sure that there are watery worlds out there that started out with an abundance of organic compounds, all the way up to...
Oh, I like that, Freemium. You said, if we don't make room to be wrong, then we are wrong. Yeah, that's very true. If we don't allow for us to be wrong in any of our analyses of the world around us, then we are wrong. Or we're only right to a certain point, right? There's a threshold of correctness associated with our viewpoint. And that's the issue that I take with experimentalists that only believe that something has to be, the empiricist. If I don't have evidence of it, it doesn't exist. That's the problem with that, because you're only right to a certain point. And I get it. You need to safeguard your mind from any kind of mind viruses out there that might turn you into, whatever, where now all of a sudden you've gone down these rabbit holes and you don't know what to believe. But I think everybody has that moment where they don't know what to believe, or everything that they've been told they feel is a lie. So you do need to safeguard yourself from that, but you need to be open to the possibilities of new discoveries.
Amino acids and even nucleotides. It's becoming harder to imagine that simple life doesn't form in lots of places. But the observation of DNA and RNA coding nucleobases could tell us something pretty profound. If all planets start with a similar chemical cocktail, maybe there's a pretty narrow path to life everywhere. One that involves DNA-like molecules. Maybe the system that codes Earth life, including your own DNA, was set by extraterrestrial biochemistry. And what about OSIRIS-REx? It delivered its sample, but it stayed out there to continue its adventure. NASA
So what he's saying is life on Earth might have already started, and then these asteroids hit and either kick-started the life, right, gave it more, or it just kind of took over and it just kind of became the life that existed here, which is, it's a powerful thing, because if you think about it, to me, that shows that even if we were to destroy the Earth, or the Earth was to in some way, be destroyed, that we can rest assured that, our DNA or the DNA of Earth will end up somewhere else. And let's say that that's in 3 trillion years. And we're having this same conversation in time doesn't matter. When you start to think about infinity and you start to think about the vastness of space, time really doesn't matter. You get much more comfortable with the idea of life and not life. And you get much more comfortable with the idea of experiencing all things. These might be my current situations, and it doesn't mean that you become hedonistic, and if you do, it's fine. But in my mind, it's just more of like I know that inside of infinity, I will experience all things possible in this form and others. So it kind of allows you to kind of relax a bit, if you're high strung and have anxiety, it's an easy way to be like, yeah, life's going to go on infinitely. It's not going to end. Look at what's happening. Look at what we're finding about the origins of our own life. Water itself isn't native to this planet. So yeah, it's a beautiful thing that adds a lot of serenity to my life.
NASA has renamed it OSIRIS-APEX and is now preparing to intercept the asteroid Apophis. This time, the mission isn't primarily to discover the origin of life, but to help prevent its annihilation. Apophis is one of the most hazardous Apollo asteroids. It has a minuscule chance of hitting Earth in 2036. OSIRIS-REx will study any changes to the asteroid that occurred during its close encounter with Earth in 2029. This will help us track Apophis more precisely. It'll also teach us more about these close encounters, perhaps allowing us to avert a future giant impact. Well, thanks for looking out for us, little buddy, and for helping us seek our chemical origins in a protoplanetary and perhaps pre-solar space-time.